Today, we have a real treat, everybody. We have Professor Mario Trapp from Munich University of Technology as our guest today. Welcome to Matrickz Tech Talk, Mario.
Hi, welcome. Thanks for having me.
All right, so here are three things you should definitely know about Mario. First of all, he is the head of the Fraunhofer Institute of Cognitive System. So he's leading a Fraunhofer Institute with around 200 people. Second, he is the chair of Engineering Resilience Cognitive System at Munich University of Technology. Finally, although he's a safety passionate guy, he rides a motorbike, ironically. So Mario, if I continue about your glorious career, I think I'll never be able to end. So without further ado, I'm going to give it over to you to tell our audience a little bit about how did your journey begin. You're heading a Fraunhofer Institute. You're a professor at the Munich University of Technology. You're passionate with safety. How did this journey begin, and how did you come to the point where you're here today?
It's actually an interesting question. So I came to safety almost 25 years ago. I was actually in the final phase when I was studying, and we had a course about safety. And this guy at this point, he actually did a quite good job because he did not tell us safety, which was a little bit boring, dusty type of topic. But what he did was he told us the story of Ray Cox. This was end of the 90s, and you remember perhaps Theric 25. This incident of this medical device in the middle of the 80s. And he told us that story of Ray Cox, who worked on the oil fields in Texas, and he had cancer in his back, and actually he was in the final stage of his therapy and was more or less cured. And then he came to the hospital to get a radiation therapy. Was the last one in the series, and then at some point he was laying down and expected the treatment. But things were somehow strange. The intercom didn't work, the cameras didn't work, but he didn't care about that. And then he heard this fuzzing noise of the machine, and nothing happened. And suddenly it felt like being struck by a lightning bolt in his back. And he knew that was not normal. That was not what it was all the times before. And then he stumbled up and laid his hand on the bench and tried to somehow get to the nurse, and then a second lightning bolt just struck into his hand. And then he somehow managed to get to the nurse, and then what turned out later on is this device was for X-ray and for radiation, and it was the first time that the safety mechanism was implemented in software. And there was just a bug in the software, and then instead of having a radiation therapy, it was set to X-raying, which means thousands the times of radiation strength was shot into his body. So after the next month, he first got paralyzed, and a few months later he died due to a software fault. And then our teacher said that if we talk about safety, it's not about standards, it's not about all of these requirements and things like that, it's about saving lives. This is one of the many stories where software killed people. And it's our job to make sure that we can benefit from all these great advantages of software without endangering people. And that's how he got me to get somewhat intrigued by the safety topic. And ever since that, for more than 20 years, I've now been working in the safety field. Did my PhD in Kaiserslautern, but in very close collaboration with Bosch, with the ESP development. So that's how I came to the automotive industry, and also joined Fraunhofer after my PhD in 2005. And there in Kaiserslautern, I built up the safety department. So at the beginning, it was somehow me. In the end, we had a huge department and then a huge division of something like 60 people. And then at some point 4 years ago, I was asked to head this institute, or even to build up this new institute for cognitive systems here in Munich. And the main scheme, if we would summarize what we do at the institute, is what we call safe intelligence. So if we now talk
Safe
about
intelligence.
safe intelligence, just 2 words to explain our story. And it's about, if we now talk about the great features of software, it's about intelligence. It's about AI, but also about all these flexibility type of things that we want to download app-like type of things. And at the same time, we have to guarantee that it's safe, because we are still in the field of safety critical systems, and that's what we do at the Institute.
Mario, you mentioned so many stimulating points. So today we're going to talk about safety and AI, and you've mentioned saving lives. You've mentioned intelligence, safety intelligence. Let's start with saving lives. So roughly about 3,500 fatalities. People are losing life in Germany in a road accident in automotive industry. So we're losing lives. Now AI is there to make life better. You know, save these numbers, take these numbers down to a level that probably will, in the best case, will have no fatalities at all. Nobody will die. So how far are we, and how is your institute getting along in that direction? When do you think we'll be able to reduce this number, and how? How do we get there?
Yeah, it's actually an interesting question. It's usually also comes along with the question, are we somehow a little bit too conservative, particularly in Germany, regarding also our safety regulations and type of things, and are the German companies just getting there too slowly? But if we break that down, and if you talk this 3,000 something fatalities, if we reduce that, for example, to urban traffic, what's currently the main market, then we talk about a few hundred, something like 600 to 800 people dying in Germany. And if you take that complete number and really think about how autonomous driving can reduce that number compared to other measures like wearing helmets for e-scooters, turning assists and stuff like that, then
so 600 to 800 in the urban market, you said.
In the urban area.
Is the rest in Autobahn?
Yeah, it's the main ratio is country roads.
Country
roads. Yeah, that's actually the most dangerous area for driving. So therefore we have to see what's actually the benchmark we have. So therefore it's if you play basketball and you don't make the 3-point throw, and then what you can do is either you train to hit the basket, or you try to shift the line. There are companies trying to shift the line. We are convinced that it's necessary just to be good enough to hit the 3 points, and that's the first thing. So therefore it's really good to have these safety benchmarks, and there's actually no societal reason to reduce the benchmarks given the potential that we have. So therefore we have to be aware that it's of course a good marketing thing to save lives, but it's also about convenience, having autonomous driving functionalities, and we don't start in cities, we start on highways. Therefore it's I guess the thing that we have, but what we see is now this dilemma that what we've done with conventional sensor technologies is already available. And the point is now people start talking about the complexity of the open world. But to the best of my knowledge, the world out there hasn't changed just because we introduced autonomous driving. What's the difference is sometimes in academia, there's the difference between environment and context. The real world is the environment, and the context is that part of the environment that we need to understand to realize the functionality. For ADAS, that's usually a set of sensor values like speed, acceleration, yaw rate, stuff like that. Once we have these sensors and can reduce the world to these sensor values, then the complexity is reduced and we can manage that. But what we can do with that simplification is already done. So now we have to understand the traffic situation. And this means now the complexity of our context is exploding, because we have to understand the traffic scene, the pedestrians, the other traffic participants, and we even have to predict what they are doing. And that's something we cannot do without AI. So now we have AI coming into play, but AI is a little bit like in Germany we have Goethe's poem about the sorcerer's apprentice who called the ghosts to the spirits and then wasn't able to master them, and then he was happy that the master came back. And if you talk AI, is a little bit like we are the sorcerer's apprentice and called the spirits of AI, but we are not able to master it. But there's no master to help us. So actually, if you talk about AI, we don't know why it's doing things and why it's not doing things. And so therefore now we have the safety challenge. And the cool thing about that is that obviously there is no car out there on level 5. And the reason for that, it's not that we wouldn't have the intelligence working in the peak performance quite well, but we don't get it safe.
So that's a super interesting point, and I'm coming back to that. Before that, you also mentioned about context, right? Because the environment is complex, but we operate in a context, operational design domain, some ODDs, as we call it in automotive. And last year in Savetronic, I mean, one of the most interesting talk was when Mercedes showed their level 3. And I mean, to the best of my knowledge, that was the first official level 3 where the OEM took the entire responsibility to even pay for if something happens. And that was pretty clever, you know, I mean, the design domain, reduction of the design domain. And later on, they even expanded the context. But that's only an Autobahn scenario. So can you talk a little bit about that? Because, you know, for our audience, you know, how did they achieve that? And can we take the same model and apply in other scenarios like urban? And let's talk about the context a little bit. How can we reduce the context and why, you know, whenever we talk about autonomous vehicle, we overrate the edge cases, you know? So why can we have practicable solution with this operational design domain or context, as you mentioned, and how do we reduce that? And what would be the future of that?
So of course, I cannot say something about that concrete project. I haven't been part of that. But in general, the idea is that what we can say is it's not possible to somehow find a generic solution saying AI is safe. But what we have to do is we need something like narrow AI with a very specific task and very specific constraints. And one of the key elements for that is the operational design domain, because context has a huge impact on the performance of our system. And there are two things. If you constrain the ODD in the beginning, or you can even have other constraints, then you can do something like conditional safety assurance, in the sense that I guarantee my safety goals under certain assumptions. And then it's much easier, it's still difficult, but much easier to say, I can assume that this and this is given, like the context it's given, it's only Autobahn, it's not raining, no tunnels, stuff like that. And then you can get rid of a lot of your problematic aspects. But then of course you have to make sure at runtime that you can detect these things, that you are in the valid ODD, that you have ODD exits.
Detection of ODD.
Exactly. So you have to become aware of your context at runtime. But once you've done that, then you get a little bit to what we actually call resilience, which means really, in fact, we want to optimize the utility of a vehicle whilst preserving safety in uncertain contexts, because we do not sell a car because it's safe, but we sell a car because of its functionality, and everybody expects that it's safe. So the question is, making it safe would be quite easy, but then there's no use case for it. And this requires that we become aware of the context, because in some cases we cannot even predict the context. And the real world is infinite, so we cannot enumerate all possible cases. And this means it's also not realistic to say we can build one-size-fits-all solutions, but we will need specific solutions for specific context conditions. And then we have to make the system aware what context are we in. In the beginning, we can say, okay, if there's an ODD exit, we have to switch off, for example, but perhaps we can also degrade functionality, decrease the speed of the vehicle, for example, increase distances to other vehicles, driving more conservatively, just like we as humans do it. If we are in a fog situation or in a traffic situation where we don't really understand what's going on here, we're driving more cautiously, more slowly, And that's something that we have to bring to the system as well. But the important thing here is what still many do in a wrong way. They put that into the functionality, into the code, might be in the neural network or some if-then-else statements in the code, but then it's an indistinguishable part of the code. And then you have to assure the complete code at all. But if you separate it, then you can say it's part of your safety concept, that you say, I know that I'm in this and that situation. In this situation, these are my safety goals that I have to meet in this concrete situation.
I like that.
And then I can show this is how I do that at runtime. And if I'm in an urban situation and lose a long-range sensor for whatever reason, I don't care that much.
I like that. So what you're saying is, I have my AI for operational functional purpose, and then I should have a separate safety mechanism, safety function that is probably deciding on the ODD, in which ODD are we in, and we should make that more resilient, more safety critical versus the actual function that's operating. Because if it detects itself, then it's the whole software we're talking about. If something goes wrong there, we have no way to get out of it.
Exactly, and sometimes it's this idea of resilience is really adapting to the context, because that's what we do. If the context changes, it doesn't make sense to use the same behaviors that we used before, because we develop today a system for a specific context.
Right.
But if we cannot anticipate that context and the context changes, the system in the new context would be unsafe, even though it sticks to its specification. So therefore we have to become aware of the context. And if we do that, it's very simplified and from a scientific point of view, not completely correct, but the idea of that is if you have n different contexts and different ODDs or micro ODDs and switch between them, then you have n assurance cases for the different things, but n very concrete and narrow things you can assure with very concrete safety requirements. But if you want to assure it as a whole, the complexity is to the power of n. So it's an exponential growth of the assurance complexity, and therefore it makes sense to split it up to these.
Okay, let's hold on to that one for a second. Can you explain that a little more? How is it like exponential versus it's linear in these two cases? So what are the two cases again for the audience, so that
So one case is really if you say, I have one case, for example, for driving on Autobahn, one for driving in urban situations, urban situations only with without a lot of pedestrians, for example, in a more peripheral area, things like that. On the Autobahn, I can differentiate on, am I is there roadworks or not? All these ODD things that we have. And we would even accept if we leave one ODD, let's say we have one assurance case for this highway type of thing, then we have one ODD for Bundesstraße type of thing, and in between we switch off the system. That's something that would be acceptable in a certain way, but then you only have to do the assurance case for this very narrow assumption that you say, okay, I can assume there's no rain. All the problems that comes along with rain is something I can ignore, as long as I make sure that I switch off the system as soon as it starts raining. And all of these things make it much easier, because it's a very narrow type of thing. You have a much smaller set of requirements, much more precise requirements. And then you have another case where you do that for Bundesstraße or something like that. But if you would now want to have a system that is more generically working in that, then you have to consider all permutations of different parameters.
Totally.
A little bit of rain here, a backlight from here, road condition here, and then you have to combine all these single parameters in combination. And that's why it makes it an exponential growth
that explodes.
of complexity.
Does make total sense. Make total sense. You mentioned people will not buy a car for safety. Safety is given. We expect it to be safe. We buy it for convenience, functionality. The upside of convenience and functionality is huge. There is no doubt about it.
Yep.
There is no question about it. So, working on a book. I call it A Brief History of Autonomous Vehicle. And I mentioned that at one point we'll look back in time and we'll find it inhuman that we drive for 7 hours. You know, it's tiring. It's inhuman, right? I mean, the way we'll look at some of the scenarios of 50, 100 years ago where people had to move heavy stuff manually. We think those are inhuman, and I think this is how exactly we're going to look at it. I mean, this is one of the biggest revolution for mankind and civilization, in my opinion, after the steam engine, the agricultural revolution. Now, with that, convenience and safety, there is a thin line where when you make things safe, people assume it to be safe. Like when I'm driving my Tesla, the Tesla is working amazing until it doesn't, right? And when it's working so good, I in the beginning I was careful, but when I'm actually gaining faith, trusting my Tesla, I'm less careful, right? So there is a thin line between, you know, when things get safe and there is a point where people will take things for granted. Where do you think we are in terms of, you know, people's perception in autonomous vehicle safety?
Yeah, I guess there are two groups of people. So there are the tech enthusiasts who just use that and go to the rear seats and let their car drive on autopilot, and because they simply trust in these technologies, and then they crash into emergency vehicles because it doesn't work. And then the others who are very skeptical about these things. And I guess that's two different things. One thing is, I guess, it's not about the driver or the car owner, because he or she is not the person who can decide alone to take the risk, because they also put children and pedestrians at risk, and they never get the decision, and they never have a chance to decide if they want to take that risk or not. So therefore it's something we have to decide as a society, and therefore it's okay to...
That's a great point. That's a great point. The pedestrian does not decide. He did not decide to take the risk of an autonomous vehicle, but he can be a victim of that risk. That's a great point.
And he's actually at much higher risk than the driver, usually.
Right.
Yeah. And so therefore that's something we have to... That's a risk decision that cannot be taken by the owner, but it has to be taken by the society. That's one thing we have to be aware of. And then, of course, it's nonetheless still the question, what is safe enough? And we have this positive risk balance type of things and all these aspects, and we would like to have very technological checklists, and then we can check, done these tests, check, done this analysis, check, and then we can be happy that everything is fine.
That's what standards are for.
Yeah,
that's what standards
exactly.
are for.
That's what we're aiming for with standards. But the big point here is that I guess it's not only but we have to consider it's a paradigm shift in how we develop systems. So it's in previous times we somehow have to consider that the history of engineering is you get a set of properties, and the quality of your work was rated depending on how good the system you developed met these requirements. Now in the engineering, in the AI community, they come from the other direction. Actually, the quality of their work is rated by the degree how they are surprised what the system is doing that they did not expect. Just look at GPT. And they are the greatest because the system is doing things they never thought of. And these are two different communities and different engineering or development cultures. And we have to consider at this point that the rules we know for software development don't apply anymore to AI. So in functionality, it's not only an evolutionary development, but it's a disruptive step. It's even a leap to a completely new paradigm. It's just like if you would have the greatest watchmaker in the world with the greatest tool, and then you have him to repair your Apple Watch. Simply doesn't work.
Love that analogy. So you just mentioned one thing that literally blew my mind, that the rules of software development does not apply in AI anymore.
Exactly.
Tell us more about it.
So what you have to consider is that's my personal opinion, but many people don't like that, because I would say often we talk about safe AI. At least at this point, I would say there is nothing like safe AI. What we can build is a safe system that uses AI. So a lot of the safety functionality, if we allocate safety requirements, most of these allocations have to go to conventional software systems doing most of the safety stuff, and we have to minimize the safety requirements that are allocated to AI components.
What is the reason?
The reason for that is if you just think there's something in AI that we can call robustness. And robustness means that if you have only minor change in the input, there must only be a minor change in the output. If you take image-based object detection, even changing a few pixels can lead to complete misclassification and completely mess up the result.
Wow.
And this also means if you now consider that if we test the software today, of course, the likelihood that in reality there will be the exact situation like in a test is 0. And the thing we can do, what's valid, is to say if we have here test case and the system passes, and we have here test case and the system passes, and we choose these test cases wisely, and we have here another test case, then we can assume that the system also works within the surface. We can build the hull between these test cases, and that's why we get coverage of our system. If we now have AI, it's not that bad anymore, but going to that direction, if you have that test case, you only know for exactly that test case that it's going to work. You know exactly for that test case that it's going to work, and for that test case. For anything in between, you have no clue what the software is going to do. This means we cannot build this hull, so we don't get coverage. So however large your n of number of test cases will be, n over infinity is always 0. That's your coverage. And that's something we have to get rid of, and that's why all these, how many kilometers need to be driven, all of these things. Of course, it's nice to do that, but as long as even minor changes can lead to the AI to completely mess up the result, and we cannot even predict that, then we have a problem. And that's why it's so difficult to come along with AI. And you can do the analogy, it's like any analogy, it doesn't fit perfectly, but just imagine if there would be a neurologist in order to say if you are going to make a mistake on the road, he's examining all your neurons and the connections between your neurons. But just doing that, he has no clue what you are going to do.
I love that.
And the same is true for us. However, we check the weights and the neurons and all these things. We simply don't know why it's doing what it's doing.
This is a great analogy. So we looking at an AI is a neurologist looking at the neurons and predicting the behavior of human, which is almost impossible task.
Exactly.
Right. And the reason to just sum up what you just said, the reason AI is not safe because the situations are infinite.
Exactly.
So there's no way we can test everything. We can test a subset of it and say with certain confidence that it is supposed to work in the other cases too. More than that we can't say, and that's why it's not safe.
Exactly.
Got it.
And the problem is also that it's not only about broadness of your test cases, so edge cases somewhere out there, but it's also, even if they are within an ODD, you have to consider that our reality is infinitesimal. So the closer,
even within the ODD.
Even within ODD.
Even within the ODD.
So the closer we get with the test case to these things, there's always this tiny thing. There's a gap, and in this gap, if there's something happens, we nonetheless have a problem.
We do.
Yeah, and that's where AI comes from. Of course, we've done a lot of work over the last 5 to 10 years to get AI more robust and all of these things. And so it's not that black and white anymore, but just to really set this counterpoint to make clear where we come from AI, because that's the characteristic of AI. We can simply not predict what it's going to do.
Totally. Wow. So let's get back to your institution and your chair that you lead at Munich University of Technology. What's your mission?
Actually, what we want to do is really to make sure that we as society, as people, can benefit from all that potential that intelligent software has, but without taking an unacceptable risk for that. So it's not about raising the finger and saying it's prohibited and that's bad and we cannot do that because we are in the global market and some company will do it.
Love that.
Yeah, and so it's about us to say it's not about prohibitions and regulations, but it's about pointing out solutions, how it can work in a safe way and nonetheless economically beneficial.
It's going to happen anyway.
Exactly.
This is what people don't understand about cybersecurity and safety. Oh, don't do it. Don't let that happen. Don't do it. But it's going to happen. Convenience will win. Somebody is going to do it. You know, the best way for you to strategically position yourself, if you think about a solution. I love your pragmatic approach. So can you tell us about some of the interesting projects that you're doing, what exciting things you're doing at the university and also at the Fraunhofer Institute?
Yeah, I guess that's a whole bunch of things. So what we try to do in a nutshell is really to bring these different disciplines together. So we have the safety engineers who really come from the safety point of view. We have the AI guys coming from the AI point of view. And we have system software engineers, because it's an AI-based system, it's still a complex software system that we somehow have to manage. And bringing them all together, not in different organizations and things like that, but really teaming up so that the safety guys understand how AI works and perhaps how we have to rethink our safety principles so that they apply to AI, but also to somehow that the AI guys learn that 90% is great for them if they have 90% accuracy, but that's far away from what we would call safe.
Totally.
Yeah, and that's what we have to bring these things together. And what we also have to learn is, that's why engineering for us is so important, even though it's not that sexy these days. But the days where we said, we have to build a safe system, and then we could simply say, okay, let's build a duo-duplex architecture and have two safe hardware pieces in a redundant architecture, or have a lockstep hardware or something like that, and then we do this, and that. There's a delay, let's use watchdogs and stuff like that, and then we just have our building blocks, and then we have a safe system. This doesn't work because the functionality is so complex that if we would find a safe solution for that, we have to reduce the functionality, the utility, so much that there's no business case anymore. So we really have to understand, for a car, for example, does it need to go 250 kilometers per hour? Or is it okay in certain situations to reduce the speed? Is it okay to switch off the system and switch it back to the user? Or is it better to keep the human out of the loop? Is it better to say we have to keep more distances? So it's something that we have to understand. What is actually the functionality we want to have? What is the utility from the business case? What do we need to earn money with our product? And then really to understand the system as a whole and really narrow it down so that we get very concrete safety requirements. If you don't get that and just make it safe in an isolated point of view, so if you have complex systems, it's a multi-objective optimization problem we have, because it's a product that doesn't need to be only safe. There's a whole bunch of other properties we have to meet, and that's how we have to understand safety. It's a part of the big picture. And then we have to narrow that down. What do you really expect from safety? Then we have to see, is it doable? Is it feasible? And then we can see, okay, is it okay to reduce the utility or to get rid of one or the other requirement? Because we have no chance to make that safe. And then it's a kind of a dialogue. And once we are there, then we can see, okay, if we have a very concrete safety requirement, and then we work with the safety guys and the AI guys, and then we can say, is there a concrete solution for that specific problem? It's just like, also today, it's often, there's often a mistake that people say, I build a component according to ASIL-C. I want this ASIL-C component. There is nothing like an ASIL-C component. There are ASIL-C requirements which are allocated to that.
Safety element out of context.
Yeah.
But like you said, you mentioned time and time again, you need the context.
Exactly.
Safety element out of context is simply means nothing in your system. This is the Like, you can't have an ASIL C component. I thank you so much for mentioning that.
Yeah, but in fact, it's also if you do safety element out of context, I guess it's a valuable concept, but nonetheless, it's called out of context. But you have to make assumptions about your context.
There is assumption. There are certain assumptions, and you have to match those assumptions with your.
Exactly, and it's just like, you have the safety manuals and type like that. We call that safety contracts. So you don't say this component fulfills these safety requirements. These are the guarantees of the contract, but you say you also have assumptions. These are the assumptions we made about the context of that component. And given that these assumptions are fulfilled, then we guarantee that our safety guarantees are fulfilled. So if you have one component from supplier A, and this has a safety requirement, no self-acceleration, then the supplier would say, okay, I cannot guarantee that because I get the speed value from that component from the other supplier. And garbage in, garbage out. If I get the wrong speed value, velocity, then I cannot guarantee anything. And then you can say, I guarantee that there will be no self-acceleration at my output, given the assumption that the input velocity I get has no too high failure mode, has no commission failure mode, has reduced noise type of thing, no drift, no offset type of things according to ASIL X. And only if that is given, then the guarantee holds. So this means you can put it into different contexts where you check if this assumption is made. And this is then a safety element out of context, if you want to say so, but you just make assumptions about the context. And depending on what the context offers, your guarantee is different.
Yeah. What's coming into the system if you cannot trust that, if it is not ASIL X compliant, then the whole thing makes no sense.
Exactly.
No matter how much you do it. So the input matters. Fascinating stuff that you're doing with your department, with your Fraunhofer Institute. So in the end, if there is we're going through a massive change in the next 5-10 years is too far-fetched. We're seeing changes every 6 months. We're seeing massive changes. You mentioned ChatGPT and all those. That's like changed the whole world in a short span of time. Now, with such a fast-paced changing environment, tell us about two things in your opinion. What is the safety risk that you see? And what would be the greatest thing in your opinion for mankind with such a fast-paced changes, technologies, and AI popping up every day?
I guess two interesting questions. It's from a safety point of view, I guess that there will be a long list of challenges. So one is certainly, if you look back how we develop safety and safety standards, so nobody has ever done a scientific proof that MC/DC coverage is enough to sufficiently reduce the failure probability of a piece of software. But we have empirical knowledge that it works.
Yeah.
For AI, we don't have these decades of experience because from technologies here to time to market, it's so short that we cannot build up that empirical evidence. So we have to do a lot of guesses and things like that. But speeding up that process, so this evolutionary type of thing, what is safe over decades of experience, won't work anymore. So we also have to reinvent how do we define what means safe actually. And that also means it's a tightrope walk. If we say for things like autonomous driving, it's in a certain degree, of course, we can up with 10 to the power of -8, -9 or whatever. But it's also a little bit unfair because we're not talking about a capacitor failing. It's not a piece of hardware that fails, but what we replace is human behavior. And that's a completely different story. And if you now want to measure safety of something that replaces a human driver, with the same metrics we have that work for hardware pieces, that's somehow probably not the right way of doing that. And that's what we see with all the SOTIF and the 8800 for safety and AI standards, where we try to find new ways, but we have to be very fast because on the functionality and technology side, AI side, we are so fast in so short innovation cycles that we don't learn at the meta level and the safety area to speed up. our processes, then we have no chance to follow the speed of technological innovation. So the innovation cycles of safety have to be much faster than they used to be today, because there used to be a barrier between all these convenience functionalities and safety critical functionalities, but that's broken up.
Totally.
The customers expect the user experience from a smartphone in a car. That's just like it is. And that's either we get faster in doing safety innovations, or we somehow won't have a chance, and anybody in the world will do it with our regulations or not. And so therefore it's not about prohibiting just because we are not fast enough. So this won't work. So that's the safety part. And what I would really like to see is that it's also a huge advantage of all these technologies coming. And it's difficult to pick out one of these things, because AI of course can help us a lot in things like labor shortage and all of these things. They can help us in climate change type of things, all these things where we as a human don't have the cognitive capabilities to do that, and building conventional software would just not scale to the complexity of the problem we face. And for all these huge problems that exceed the complexity we can manage with conventional software, AI can help us to come up with solutions. And that's why I think it's very important, even as a safety engineer, to step away from the prohibiting perspective to the enabling perspective. And what does safety mean? And really also think about safety and long-term type of things. Here it's even a kind of spiritual type of thing, but if we pollute our environment, that's in the end it will also kill a lot of people. So it certainly also becomes kind of a safety issue. So all of these things are something we have to consider in the risks, but that's a societal dialogue. That's something not we as engineers moderate, but others moderate. But as a society, we have to learn to get faster to see, because for us, it's safety means residual risk is lower than acceptable risk. The question what acceptable risk is a societal
question. Love that. So number one is, if we do not innovate safety faster, or at least at the same pace as innovation, we're doomed. That's the first point. The second point is AI is coming up with a huge opportunity that's going to benefit the society in a multifaceted way that has no end. Love that 2 point. Mario, thank you so much for joining our podcast.
Thanks for having me.
Thank you so much for watching or listening. If you have questions, comments, please feel free to write in the comments section. I'm pretty sure Mario will be happy to take your questions, and I will be personally taking it. It was Professor Mario Trapp. Thank you so much for being with us. Thank you. See you in the next episode.
Thank you.